Okay, this section here is going to be in section 3.7 of our text, and it's going to be using the vertex formula for the quadratic equation. Now, the vertex formula for the quadratic equation is given on page 97 of our textbook. And for a standard form of a quadratic equation that's in this form here, y is equal to ax squared plus bx plus c, the vertex form, or the vertex of that, I guess, not the form, the vertex of this formula would be found by simply plugging in these formulas. There's the x point, minus b over 2a, and the y point would be 4ac minus b squared over 4a. Now, I started an example here already, and if I had an example, say y is equal to 2x squared minus 3x plus 5, and I wanted to find the vertex, all I would do is I would say, okay, a is 2, negative 3 is b, and c is positive 5. And then I would just plug it into the formula. So that's what I started doing here. The formula for the x point is negative b over 2a, so negative 3 over 2 times 2. In our case, that gives us a positive 3 over 4. That is our x point. Now we can do the same for the y point of the vertex. So that would be 4 times a, which is 2, times c, which is 5, subtracting b squared, which is negative 3 squared, over 4 times the a point, which is 2. So working this one out, we have 40 here. 2 times 4 is 8 times 5 is 40. Subtract negative 3 times negative 3 is 9 over 8. So in our case, we've got 41 over 8. So then our vertex for this particular problem is going to be at 3/4 and 41/8. And that's how you do a problem like that. Just simple use of the formula. Now, I'm going to move on to a word problem, and I have a couple of word problems, but in this tutorial I'll probably just be able to do one that uses the vertex formula. So here's my first problem. Let me just put that up there so we can see it. Okay, one number is 15 larger than another. What is the smallest value of their sum of the sum of their squares? And what are the two numbers? Okay, so first of all, x is one number, and y is another number. The other, let's say. I do x and y like that. Well, we have the sum of their squares. So x squared plus y squared is going to equal basically the smallest sum. So smallest value, or if you like, a minimum. If you work later in math, there will be a much simpler way if you go on to calculus to do these minimizational problems. But at this point we don't know that yet. So here we have x and y. X squared plus y squared gives us some of the smallest value. And we have to get it all in the form of one variable. So we know that y says one of the numbers is 15 larger than the other. So let's say y is the larger number. So that would be x plus 15. So if we can sub that back into here now, x squared plus x plus 15 squared is going to give us a minimum. Or it's giving us, let's say, a minimum as a function of x. That's how I'm going to write that. Meaning that this is going to give us the smallest value. I'm going to write it in that form. So if I work this out, I get x squared plus x squared plus 30x plus 225 is equal to this function, quadratic function. So we want to find the actual function is 2x squared plus 30x plus 225. is equal to that function of x. So we want to find the minimum value there, so we can plug in into our quadratic formulas to find the x point, and also to find one of the numbers, and then also to find what the mx value would be, or the minimum value would be, and that would be our y point. So let's plug in. So a is equal to 2, b is equal to 30, and c is equal to 225. They're all positive numbers there. So let's plug in. We got minus b over 2a. So that would equal negative 30 over 2 times 2. So this would be negative 30 over 4. If we work that out, that's 7.5, negative 7.5. So that's the x point, or one of the values. Now the other way to figure out, we could figure out the other one now just by adding 15 to it. So y would be the other one. Y would equal, I guess I shouldn't use the y variable there, but that's okay. So that would be negative 7.5 plus 15. So that's going to equal 7.5 positive. So our two numbers are 7.5 negative and 7.5 positive. Okay, and if we want to find their maximum value now, we could simply just plug them into here to find the smallest value, 7.5 squared and negative 7.5 squared, and add them. Or we could plug them into the second point. And that's what I'm going to do. I'm going to plug it into the second point. Let me just check my field of view so that I have enough room here. So there's two ways to do this, obviously. So I'm going to plug it into this formula. The second point is 4ac minus b squared over 4a. So this would give me 4 times a, and our a is still 2, times c, which is 225, over, or sorry, not over, we still have to subtract b squared, which in this case is 30 squared, and that now is over 4 times 2. So this gives us, okay, when we work this out, 8 times 225, that's going to give us 1800, subtract 900 over 8. So our answer is 900 over 8, which if we work that out, that's 112.5. And that's our smallest value that we'll get. So that we can say our smallest value is 112.5. And that's an example of a problem. In our next tutorial, we'll look at a problem that deals with something very similar to that area, but it'll be more practical in the sense that we'll be using areas in it.